Hello, Intro to Stats students. Today we are going to learn example 3.3, page number 139. This is from Statistic through applications, Yates, Starnes and more. So example 3.3, this is the next part of section 3.1, that's about sickle cell anemia. Example talks about this disease, which is actually inherited disorder of red blood cells, and the symptoms are the patients they have severe pain and many complications, and in order to treat that, there some clinical trials were done, and a kind of drug that's called hydroxyurea being used for that. So they just checked how much it is effective. So what they have done in order to done the experiment, they have done some clinical trials. As I told you before, that a clinical trial is a kind of trial where they just check how much the drug is effective on patients for a certain disease. So in this clinical trial, we're just going back to clinical trial. In clinical trial for sickle cell anemia, they had 299 adult patients, and out of those patients, they were actually called subjects for this experiment. And first, they thought of checking how much is that effective. So they planned to have two groups. So one was getting the treatment and other was not. So 299 adult patients, they randomly assigned them to different groups to avoid confounding or lurking variables. Maybe here lurking variables could be an example. Suppose someone if knows that I'm being a subject for experiment, I'm being treated for this for some intention, then they may behave differently, or random assignment is done to avoid bias. Maybe a doctor may choose someone who's really sick to assign it to the group where the active treatment for the disease is given and not the placebo one. So in order to avoid these confounding or lurking variables, the assignment was done random by simple random sampling. Now there were two groups created for that. So first group was 152 patients and second group was 147 patients. And how these two groups were created? It was created by simple random sampling to avoid any confounding. So these two groups, they were given different treatments. So group 1 given treatment number 1 and group 2 was given treatment number 2. Group 1's treatment actually has the active drug over there, active treatment, which they were given hydroxyurea. And the other group, they had a placebo. Means for this experiment, they were treated the same way, they were chosen of same age and as similar they can make it. Both groups, they kept it the same, and for treatment wise, they were treated the same way, same kind of timing, same kind of checkups, everything same, no difference in treatment. Only the treatment was the difference was about the drug being given. So the first group, they got hydroxyurea, other was placebo, some certain thing which may taste and look similar to that but doesn't have any impact like a chemical. So once the treatment is done for both groups, they compared. How can you compare the effectiveness? Because they had sickle cell anemia, they have severe pain. So comparison of pain, that could be best thing to figure out whether the medicine was effective or placebo was effective. So afterwards, they figured out, just in the middle of experiment, they stopped ahead of schedule because hydroxyurea had fewer pain episodes than placebo group. So they had to stop because they came to a conclusion that hydroxyurea group is doing much better and they're improving in terms of their health instead of placebo one. Now, whatever we have done till now, like we created two groups and we assigned them different treatments. The assignment is very important here. This random assignment, that's really important because that's only going to lead us unbiased conclusion. Otherwise, there may be several confounding or lurking variables included in the result and may not be the fair outcome. What you have to do, so for that, the whole procedure, you call it comparative, randomized comparative experiment. And the things you need to keep in mind, the comparative experiment is basically comparison of treatments. You need to figure out which one is effective, how the one does when it is compared to other one. So random assignment is very important. It has to be random. Impersonal choice should, so the choice person's personal interest should not be there while assigning the treatment. One group for each treatment. If there are 3 treatments, you have 3 groups. If there are 4 treatments and you want to compare them, you have 4 groups. And then number of subjects in each group, just keep the same size and try to keep them as similar as possible so that your result is not having variation in it. Treatment assigned to each group, then assign treatment to each group, and comparison of response variable. Whatever you're trying to check, just try to compare that. All right. So after that, we have last definition in this chapter, in this part, example 3.3, that we call control group. All right. The control group is basically a group which has a, you can simply say it is a placebo group, and it's a group without active treatment or for different treatment. Like sometimes it may have without active treatment comparison, or sometimes it may have like some kind of drug is already in the market for specific disease and they invented new drug and they want to compare whether the new drug is better than the previous one, the existing one. So that could be assumed as a control group which is already existing, and then other group you will have the new drug. So that's all for 3.1. 3.1, this part, where the example 3.3, it's about sickle cell anemia, and I'm in the next example 3.4, I'm going to explain it. Stay safe. Any question, please leave in comment box or loop mail me. Thank you so much.